Okay, so in today's video, we will be talking about the Bayes Theorem. And specifically, the Bayes Theorem we will use in events where there are two events. So, first of all, what is the Bayes Theorem, right? So the Bayes Theorem is basically the probability of an event happening based on the prior knowledge, or we can say based on the prior knowledge that an earlier or another event has happened. So this is basically a conditional probability. Now we know that the typical Bayes theorem that we use really defined as the probability of A happening multiplied by the probability that B multiplied probability that B happens given that A happens divided by the probability of B. Now, but in today's video, we will be going over the two event Bayes theorem. Which uses the formula the probability of A I given that B happens, where I can be event 1 or event 2 equal to the probability of AI multiplied by probability of B given AI happens divided by the probability of A1 multiplied by probability of B given A1 plus probability of A2 multiplied by probability of B given A2. So basically we can choose whether we want to find the probability of event 1 and we divide by the bottom part, or we can find the probability of event 2 divided by the bottom part. Now this is a very useful theorem, but you will have to first understand how it is used. So let us try to first apply the formula to one question, and then we'll move on into a real life situation question. Okay, now moving on to the first question. 1. The prior probabilities of event A1 and A2 are P A1 equals 0.4 and P probability of A2 0.6. Also known that probability of A1 and A2 is 0. That means they are mutually exclusive, right? See, means that it cannot happen together. Such an example could be that whether you exercise or you don't exercise, there's no middle, right? So you can be either exercise or not exercise. You cannot be exercising and not exercising at the same time. So the probability of that is 0. Okay, now continuing, suppose that probability of B given that A1 happens in 0.2 and probability of B given that A2 happens in 0.05. Now we want to calculate the probability of A1 given B and probability of A2 given B. Now, first of all, you can input the formula. Now let me just copy the formula above. And paste it here. Here. Now we want to compute probability of A1 given B. So the probability of A1 multiplied by a given B happen equal to the probability of A1 multiplied by probability of B given A1 divided by probability of A1 multiplied by probability of B given A1 plus probability of A2 multiplied by probability of B given A2. And thus, we can just substitute into the formula, right? So probability of A1 is 0.4 multiplied by probability of B given A1 0.2 and divided by the probability of A1 multiplied by probability B given A1 plus probability of A2 happening, which is 0.6 multiplied by probability of B given A2 happens is 0.05. And all you have to do is to input that into the calculator, and what you will get is 8/11, which is also equal to 0.7273 approximately. Now, moving on to the second part of the question, which is to let me change the color. Give me a second. Alright, to find the probability of B, A1, A2, given that B happens. Right? Now let me make this. Let me bring this over to the other side. Right? Equal to probability of A2 multiplied by probability of B given A2 divided by probability of A1 multiplied by probability of B given A1 plus probability of A2 multiplied by probability of B given A2. Now, just substitute this into the formula. Probability of A2 is 0.6. Probability of B given A2 is 0.05 divided by probability of A1 0.4 multiplied by probability of B given A1, which is 0.2 divided by and plus 0.6 multiplied by 0.05. And what you will get, just substitute into the formula. You will get 3/11, which is approximately equal to 0.2727. And what you will realize is that when you add up these both probabilities, add up, they will equal to 1, because the probability, there's only two events, right? Only one event can happen or another event happen. There's no other option. Alright, now moving on to a more real life situation. Drug test for athletes has a 5% false positive rate and a 10% false negative rate. Of the athletes tested, 4% have been using the prohibited drug. If an athlete tests positive, what is the probability that the athlete has been using the prohibited drug? Now, this may seem complicated at first, but let's break it down step by step. Now, if we want to use the formula, we have to substitute some variables. So now let A1 be the fact that the athlete uses drugs. A2, athlete doesn't use drugs. And that B equals that the athlete tests positive. And inverse of B is that the athlete tests negative. Now that we have this in place, we can start to develop our formula, right? A drug test for athletes has a 5% false positive rate. Now, what does that mean? That the false positive rate, right? False positive rate means that basically the probability. Now let me use a different color. The probability that the athlete at a false positive rate, this means that the athlete is not using drugs but test positive, right? So the probability that the athlete tests positive, given that he's not using drugs, is 0.05. Right? Now, and a 10% false negative rate. What does it mean? That means the athlete is using drugs, but he gets a negative result, right? So the probability of getting a negative result, inverse B, given that he's actually using drugs, is 0.10. Now, of the athlete tested, 4% have been using the prohibited drug. What does it mean? That means that probability of A of using drugs is 0.04. Now, if the athlete tests positive, what is the probability the athlete has been using a prohibited drug? So, what we are trying to find here now is that the probability, if the athlete tests positive, what is the probability that the athlete has been using a prohibited drug? Right? This means we are trying to find the probability that the athlete is using a prohibited drug given that he tests positive. Right? Now, before we continue, based on the information they have given us, we can actually infer quite a lot of things, right? So, here, first, the probability that the athlete tests positive given that he is not using drug is 0.05. That automatically means that the probability that the athlete tests negative given that he is not using drugs is 0.95. Because you can either test positive or negative, right? So there are only two events. So you take 1 minus 0.05, you get 0.95. And definitely, also, we can infer from here that the probability the athlete tests negative given that he's using drug is 0.1. What we will get is the probability that athlete tests positive that given he's actually using drugs is actually 0.9. Because 1 minus 0.1 is 0.9. Right? And also here, naturally, we can use to find the probability that athlete is using drugs is 0.04, the probability that athlete is not using drugs is 0.96. Right? Okay, now we can move on into finding the solution to our question. The probability the athlete is using drugs given that he tests positive. Now we can just substitute the formula, right? Probability of A1 multiplied probability of B given A1 divided by probability of A1 multiplied by B given A1 plus probability of A2 multiplied by probability of B given A2, right? And what we will get, probability of A1 is 0.04 multiplied by B given A1 is 0.9, right? And probability of A1 0.04, 0.9 plus probability of A2 is 0.96 multiplied by probability of B given A2, which is 0.05. Input this into your calculator and we will get the answer. We got 3/7, which is approximately 0.4286. And this means that there is a 42.86% chance probability that the athlete tests positive is using drugs given that he tests positive. Now you can see why the Bayes theorem is such a useful tool in all kinds of everyday situations.